Hear me?
Yes, sir.
Hello, are you able to hear me, guys?
Yes, sir.
Okay, fine. Let me share my screen. Okay, hope you're able to see my screen.
Yes.
Okay, so let's start our today's session. So today's session is completely depending on GCS, guys. So today we are going to discuss in-depth things related to GCS, Google Cloud Storage. So this Google Cloud Storage is of object storage. Be very, very clear. The internal architecture of Google Cloud Storage service is of object type storage. We have different types of storages, guys. We have block storage. We have bit type storage. So different types of storages we have, but this cloud storage is of object type. Okay, so that means object type storage is designed for very huge volumes of data. Be very clear. Object type storage is designed for very huge volumes of data. Okay, and this type of object storage is completely supports unstructured data storage. Okay, very huge volumes of unstructured data storage. Okay, so object storage is a storage technology which can be utilized in all the cloud based storages. You take AWS S3 buckets. In AWS, we call it as S3 buckets. In Google Cloud, we call it as Google Cloud Storage buckets, GCS buckets. Okay, and similarly in Azure, we will call it as data lake storage containers. Okay, so data lake storage containers. So we have three cloud providers and we have three storage services available, but all three storage services are following object storage type. Be very clear. Object storage type. What is this object storage type? This object storage is basically meant or designed for very large volumes of data storage. Okay, and along with the structured and semi-structured, it also supports unstructured data storage. Okay, you stream videos to the storage, you stream images, you stream PDFs, or you store anything, right? So from the application you can directly stream video also to this kind of a storage type. So that is the power of this object storage. And internally it stores in a distributed fashion. Okay, internally it stores in a distributed fashion. So they will take bulk on cloud based storage systems, and then they will set up this object storage service on top of it, and then we can use it like from the GCS service. Okay, and each and every file that you store, each and every content that you will store in Google Cloud Storage, or for that matter any kind of storage, object storage. So it will be treated as a single object. Be very very clear, it will be treated as a single object. Let us take an example. I'm storing a employee.csv file in Google Cloud Storage. It will be treated as a object. Okay, it will be treated as an object. And now this object will be having a metadata. Okay, so it maintains the metadata, and it will also maintains the identifier of that object. Okay, so what it maintains in the object storage, guys, when we store any file in object storage, okay, now the technology, object storage technology, will treat that file as an object. Okay, will treat that file as an object, and it will store the metadata along with the file. It will store the metadata of the file. Metadata meaning what is the file name, when it got created, all the metadata, right? File name and the directory path, and then the size of the file, and then the created date, everything, the metadata of the file will be stored. And also the easily accessible identifier, it will create on the fly index or identifier for easily accessing for that an object, for that object. So it will be, most of the times it will be object name. Okay, so it will store that identifier also along with the metadata. So because of this reason, when you generate any kind of uh, you can also, you can generate all the URLs also to the objects directly. Okay, so here the core takeaway is Google Cloud Storage, or else S3 buckets, or data lake storage in Azure, any kind of cloud storage system is of object type. Okay, so object type of storage is a technology, or it's a storage architecture for storing large volumes, or large volumes of structured, semi-structured, or unstructured data. But it is designed or meant for uh, unstructured data storage, huge volumes of unstructured data. Right till now, we don't have any kind of a storage system which can store very large volumes of unstructured data. Right, in cloud, in on-prem, we do have such kind of a distributed system called Hadoop file system, but in cloud we don't have that kind of a technology. So that's where they actually came up with this new technology called object storage. Okay, so now this is a storage technology, and where actually we can store very huge volumes of unstructured data. Okay, and each piece or each file in the object storage is an object. Be very very clear, each file in the object storage is an object, and uh, it is stored in the distributed, along in a distributed fashion, along with its metadata and the unique identifier for easily access and retrieval. Okay, so this is something that you need to understand. Any questions or queries here, guys? Are we clear? Are we clear on this?
Yes.
Okay, so now we have four different storage options in any kind of storage platform. So one is the standard storage, near line storage, cold line storage, archive storage. Okay, so the type of each storage is having its own functionality. Okay, for example, standard storage. So standard storage, it stores the data that is frequently accessed. Okay, so nearline storage, it is actually a highly durable storage and storing infrequently accessed data. Okay, so and then cold line storage, it's very low cost, and then durable storage service for storing infrequently accessed data. Again, archive storage, it will be used for the data archiving, online backup, and disaster recovery. For these activities, we'll use this archive storage. and it can be treated as a very low cost storage. Okay, but it depends, guys. So in your project, which type of storage admin will select, it depends on them, because majority of the times people will go for standard storage where the data can be accessed very frequently. We treat that data as hot data. Okay, so we have, as far as types are concerned, we have standard storage type, nearline storage, cold line storage, and archive storage. Okay, nearline storage, cold line storage, and archive storage. So these are the storage types that we can that we can see, but we don't deal with them majority of the times. Admins will create the buckets for us. Admins will create projects for us, and they will select these types depending on the solution project needs. Okay, so that I just want to give an introduction. What is Google Cloud Storage architecture? How actually it is defined in the backend. So this is object storage type. Okay, so be very clear on that front. Okay, Google Cloud Storage is a service that you are using in the Google Cloud for storage. Okay, Google Cloud Storage is the service name that you are using in the Google Cloud platform, but internally, the storage architecture for Google Cloud Storage is object storage. Okay, so you can go and explore what is the architecture of object storage, how it stores objects. You can go and explore, but that much understanding is needed for you. But for our sessions, it is not needed. For us, it's actually looks like a directory structure. Okay, so people who are interested to go and explore, I always recommend to go and explore, look out some videos related to object storage, how actually it will be created, right? So for now, understand this object storage is a technology or a storage architecture that is designed for very large volumes of data. Okay, and that large volumes includes it, structured or semi-structured or unstructured, but it supports very large volumes of unstructured data as well, along with the structured and semi-structured. Okay, so it stores every file as an object in the object storage architecture, and every object it will store for every object it will store the metadata and easy access identifier or unique identifier it will store, so that we can access that object very easily. Okay, so this is actually the introduction of Google Cloud Storage. And we already created a Vertex AI notebook in our last session. Okay, I'm just logging into that Vertex AI notebook. Here, if you see, you can always use your Vertex AI notebook to create your buckets, right? Or using a command line, you can actually create the buckets. Okay, but for us, we have a flexibility in user interface UI to create the buckets. We'll just go and utilize that. Real time, you remember, you don't create any buckets as such. Be very clear. So your admins or your project creator will create the buckets for you by default. Okay, so I'm just going to cloud storage, and here I don't have any buckets as such. So to understand this object technology, this object storage type technology will be having a root container or a root bucket, which is actually a root directory, which is actually called as a bucket. Okay, so under this project, and the root directory will be the bucket. The root namespace will call it as. Okay, so that namespace, from that namespace, your directory structure will start. Okay, so here, if you see, create. Okay, the bucket name. I'm just giving dev de training hyphen default. Okay, so this is my bucket name, and then here you can see the pricing also. So 0.026 dollars per GB per month, right? So that's how your storage is very cheap out of all the services that we have in the cloud platform. This storage is the cheapest service. Okay, so continue, and then here you can select. I told you, right, the regions, zones, multi regions. So we can go with the multi region. Okay, so choose a storage class for your data. Okay, so choose a storage. See here you can select standard, nearline, cold line, archive, right? So I'm just the default storage class is the standard one. So I'm just going with the standard. Okay, and then you can access control, right? So this is something prevent public access. So your data is only restricted to show to your project accessed users. It is not for the everybody in the GCP platform. So I'm just enforcing that public access, right? And then choose how to protect the object there. So this soft delete policy enabled for 7 days. So data retention, how many days you want to store your data in the cloud storage. So by default, it is 7 days retention, retain objects for 7 days. And then you can apply the retention policy for your objects. Okay. So set bucket retention policy. So in the bucket level, you can apply the retention policy. And for the object levels, you can apply the retention policy. So here you can see the objects. Also, I'm just keeping 2 years for an object. Okay, so that means every file that I put in will be stored for 2 years. Okay, and similarly, retention, right? So for your bucket, so set bucket retention policy. So here, based on the creation date time, you can select the retention policy. So we call it as a retention policy. So in real time, for buckets, people administrators will keep the retention policy. So for example, in my organization, it is 2 years. So 2 years, whatever the files that will be there from past 2 years, they will be automatically deleted. Okay, so it's a organization call or a architect call. How many days of retention he need for the objects and as well as for the buckets. Okay, so that is something that you need to understand. Okay, so for now, I'm not mentioning any kind of retention for the bucket, but I have mentioned retention for the or else I will keep it as is by default. Okay, so now this is how you will actually add all your options and then create your buckets, right? So once you create your bucket will be created. Okay, and as I already told you, inside these buckets, you will be storing the objects. Okay, you will be storing the objects. In our terminology, the files. Okay, so objects meaning files. So here you created the bucket. So inside the bucket, it is similar to our folder structure, right? So create folder. So I'm just creating a directory called a data. Okay, or else I'll just use small keys only. So I'm just creating a folder called data. And then inside data, again, I'm just creating a folder called raw zone. Okay, raw underscore data underscore layer. So this is my subdirectory. Okay, so then again under data, I will create another directory called stage underscore. Okay, similarly we will create one more directory called See, I'm creating three directories. Okay, so one is a raw layer, and then a stage layer, and then target layer. Okay, so now you can always upload objects into this directory. You can always upload objects into this directory. Okay, so let me just, yeah, so you can always upload objects into this one. So I'm just going to raw data. So how I can upload. So here we have three different ways. Be very, very clear. Here we have three different ways of uploading the data into GCS. So in real-time projects, okay, in real-time projects, so here let us say manual upload is the one of the loading data loading option that we have. Manual upload. So what do I mean by manual upload? So here if you see, I just entered into this directory, and then, okay, so I will take this later. Okay, see here, upload files. So I'm just going into here, and then I'm just taking one of the text file, and then I'm just uploading it. Okay, so this is one of the way that we can upload files into GCS or Google Cloud Storage. Okay, so, and you can always delete this. Okay, so, and then this is one way, and then second way. What is the second way? So again, using a Python client to load files or data into GCS. Okay, and then the third way of loading files is using uh, any kind of uh, data transfer tool or application. Okay, so we'll be seeing a lot of ETL tools, right? So those using those ETL tools also, we can actually ingest data into this Google Cloud Storage. Okay, so we'll see the Python client today, how we can ingest the data to Python, using Python to GCS. And then tomorrow we will see loading the data from a tool, a third-party tool called NiFi. Okay, so I will suggest you to go and explore about NiFi service or tool today. So because this is a very, very powerful tool for data orchestration and data transfer. So for example, in real time, you'll actually get a requirement in such a way that, hey, I have 100 tables in Oracle, and then go ahead and create a data pipeline for ingesting all the 100 tables data to Google Cloud Storage on a daily fashion. This is how you will get the requirement, right? So in that case, the two ways you have: using the tool or using the framework, right? So you can develop a framework, or you can build a pipeline using a tool, right? So we'll see two options here. Okay, so we are not skipping any of the options, because everything is needed for us people who are interested on a because at the end we need to develop a project, right? So in that project use case, people can select any of their choice, right? So they can use Python client, or they can use a tool also. So that's why we are planning to discuss both. How to load the data to Google Cloud Storage. For this, we are seeing two major real-time implementations. Okay, manual upload is nothing, so it is just for your testing. But if you want to schedule it, if you want to make it run on a regular fashion, it should be in either script, or it should be developed from a tool, right? So we'll be seeing these two options. Okay, So and today we'll be having a couple of tasks as well. Okay, so be ready for it. So here, as I've already told you, so we created one bucket, and then we created the sub folder structures. Okay, so raw data layer, stage data layer, and then target data layer. So this is the subfolder structure that I have, and you can always access your Google Cloud Storage from your notebook. As I already told you, this is a central place where you can access all the services, right? So let us see. If you see, in the raw data layer, if you simply upload a file, I'll show you how actually you can check the metadata of that file, right? So here, if you see constraints examples is my file name. I'm just trying to upload my file to my GCS. So it got uploaded. So when you click on this file, when you click on this object for that matter, if you see the metadata, right? Type, what type of file it is, size, and then created, last modified, what is the storage class, and then public URL not applicable because we restricted the public URL access. And then here, if you see the object URL, directly you can access this object by using this URL, right? So by using this URL, so you can always access the object. Okay, and then if you want to see this, right? So that is the biggest advantage in cloud storage. You can directly access the object because it will stores its unique identifier for quick retrieval, right? So you can always access this. See, if you want a full path of your object, so this is how you can get the full path, which is actually Google storage colon slash slash the bucket name. From there, the subdirectory structure, and then the object name at the end, right? So you need to understand this. So, and then edit access related stuff you can do, and then version history, all these things will be there, but you don't play with them in real time majority of the times. So here, if you see, you have a gsutil URL. So gsutil meaning a Google's utility. Okay, so this is a storage utility that got built. Okay, so to play with the storage from the command line. Okay, for example, if you see, I'll just give you some glimpse of the Linux. People who did not know what is the Linux operating system, uh, and then how it works. See here, guys, in real time, most of the machines or servers will be hosted with the Linux operating system. Okay, but here, if what is the difference here in Windows? If you see, we can go and play with this folder like a structure, and very good user interface and all, right? But in Linux, you don't see all those things. You'll see only the command line, right? So if you want to see the directories in here, you'll use ls command. Okay, and then if you want to see the detailed information, you'll use ls-lrt. List is the command that we will use to see the directories that we have. Okay, and then if you want to switch to the directories, then you will use cd change directory. Okay, we call a folder in Windows as a directory in Linux. Okay, so cd tutorials. Okay, and then if you go like this, you can give list. See, under tutorials, you will see all these examples, right? So list is a command that we will use to list the uh, folder structure or files in the directory. And then you can always use change directory command to switch between the directories. Okay, and then here, if you see, I'm using cd dot dot, so it will go one directory back. Okay, you can use pwd to check in which directory you are in. Okay, so these are few commands, guys. You need to be very clear on it. And then here, if you see, if you want to create a directory, you need to use make dir command, mkdir. Okay, so mkdir, let us say test. Okay, I created a test directory under root directory called slash home slash Jupyter. So your directory structure will start from the root, which is actually slash. Okay, so slash home, under root directory you have a home directory. Okay, under home directory you have a Jupyter directory. Okay, so this is a Linux operating system structure. Okay, you need to understand this, and you need to learn it. There is no other go to escape from it. Okay, so here few commands only, guys. So mkdir test, you, I mean, list the files in a directory, and then switch between the directories, and then check the current directory. So three commands we have seen. And then to create a new directory, we will use mkdir. Okay, so mkdir is the command to create a new directory. So now I created a test directory. Now let's say I want to create a file in the test directory, right? So I'm going into the test directory, and then vi is a command that we will use to create a file. Okay, so vi is the command. Once you click on vi, you need to press I, you to go into the insert mode. Okay, and then employee ID, employee name, comma salary. Okay, and then one Venkat 5000. So once you entered your file content, then you need to click escape, shift, escape colon, WQ, exclamation, enter. So this is how you'll add content to the file, and then save it, and then come back to the terminal. Okay, so you need to go and explore the Linux commands, guys. So I request you to go and explore Linux basic commands. You just try to search, and then practice all the Linux commands that you have, right? So and get some knowledge on the Linux. I'll give you some important commands here, but I suggest you to go and practice the Linux commands. Okay, so here if you see, I have a file that got created in the test directory. If you want to see the file content, right? So cat is the command that we will use. Okay, so cat is the command that we will use. So Linux is all about commands, guys. So how many commands, how more commands you know, that much proficient in Linux you are. Okay, so now I have the file in my test directory, and if I want to copy the file between the directories, then you'll use a command called cp. Okay, cp emp.csv, right? So I'm in the test directory, and I'm directly copying this file. So cp source path and the destination path you need to give. So I'm just copying it to slash home slash Jupyter, and then under Jupyter I have tutorials. So I want to copy this emp.csv file to the tutorials. So every time, it's always good practice to pass the source path as a fully qualified path. Okay, so fully qualified path meaning, so this is the fully qualified path. Okay, so cp copy is the command that we will use to copy a file from one directory to another directory. Okay, so now you're copying employee.csv file from test directory to the tutorials directory. Okay, so now when you run this command, so it will be copied, and you can always list this directory, right? So to check whether your file got arrived or not. So here it is your file, right? So these are some commands, right? So if you want to remove a file, you can always use rm command. Okay, so if you want to delete that file, you can use rm command. Okay, I want that file back from that directory again, so you can use this copy command. Okay, again, so dot represents the current directory in the Linux. Okay, so that's why I've just given the dot here, so that it will copy into my current directory, or else you can give the complete directory name also. Okay, so we have seen pwd, we have seen ls command, we have seen copy command, we have seen remove command, right? So if you want to rename a file, right, if you want to rename a file, so you can also do that. So here, if you see, I have a emp.csv file, and for renaming this file, we'll just use mv command. Okay, mv emp.csv to emp underscore data.csv, right? So move is the command that we will use to rename a file. Okay, and similarly there is one more functionality to this move, right? So this move command will be utilized to move files between the directories. Okay, so cp is equals to the control c control v in Windows. Okay, move is equals to the control a x control v, because cut paste. So move will do that similar activity, but if you want to only copy, then you'll use cp command. Okay, so what are all the commands that we have seen, guys? What are all the commands that we have seen? We have seen ls, we have seen pwd, we have seen cp, we have seen move, rm, cat, right? So these are the basic commands, basic Linux commands. Okay, there are a lot of hell lot of commands that you have in Linux, but these are the basic commands that we need to understand from the Linux. Any questions, guys? Any questions or any queries? Are we clear?
Yeah. Yeah.
Okay, so I request everybody to go and explore about the Linux commands. Okay, those are pretty important in the real time when we are working in. Okay, so now let us understand how actually we can connect to GCS from our Vertex CI notebook, right? So here, if you see, I have this emp.csv file, right? Or else I have this already a object that I got uploaded. So you have a GS utility which Google has built, Google Storage Utility. So GS util, and then you can use all your Linux commands, right? So if you simply use GS util cat, so and then your Google Cloud Storage file path, complete path, so you can read that file from here, right? And similarly, when you are working, you may face few situations wherein you may be working from this Linux machine, and you need to upload some files to Google Cloud Storage from here, right? So in that cases you'll simply use gs util, that storage utility name, and then cp, the same command, and then here you have emp.csv file and in this directory, right? So and then you want to copy that emp data.csv to this directory. Okay, here, so when you do this, it will copy your file from your local Vertex AI Linux machine to the Google Cloud Storage. Okay, so I just copied the wrong URL. So let me copy the right URL. So gs util cp emp underscore data.csv, and then the directory path. Okay, see, you copied an object from your local machine to the Google Cloud Storage. Okay, so this is one of the utility that we will use
to connect with the Google Cloud Storage from the Vertex AI machine that you have. Okay, so now here, if you can see, you can always load files using the Python client as well, right? So Python client is one of the way to load the files, GCS files. So that also we'll discuss, okay, in coming next 15-20 minutes. Let us understand that Python client as well. But before that, I want you to get some clarity on this Vertex AI notebook and then Google Cloud Storage. So we know how to copy files between Vertex AI notebook and then Google Cloud Storage, or else from the Google Cloud Storage to the Vertex AI notebook. Okay, so similar, so how we can copy? Here we have seen from Google, from Vertex AI notebook to the Google Cloud Storage, but how we can copy the files between, how we can copy the files from the Google Cloud Storage to the Vertex AI notebook? We can always use the same command, gsutil-cp. In the source path, we will provide the Google Cloud Storage path, and then the destination path will provide the our local notebook path. So this is how we will copy files between the Google Cloud Storage and the Vertex AI notebook. Okay, so you need to understand and explore more on the Linux commands. So because your GS utility will always use the Linux commands only. Okay, so this is how we integrate between Vertex AI notebook and then Google Cloud Storage. You can always write your Python codes in this Vertex AI notebook. Okay, and you can store, you can run, you can schedule them using cron tab. You can do anything in the Vertex AI notebook. Okay, so before going and creating our Python files here, let us understand how we can actually write a Python code to interact with Google Cloud Storage. This is very important, guys. Okay, so here I have created the bucket. I have created the bucket and I have the directory structure. Okay, and simply I want to load the files from the external systems. Okay, from the external systems, I have a on-premise server. From there, I want to push the files to my Google Cloud Storage. So in that case, your Python libraries or Python client based working will really help you uh, to communicate with the GCS. Okay. Now let us start with the load. How we can load files from our local system to the Google Cloud Storage. Now, for any kind of a system, if you want to communicate, we need authentication mechanism, right? So we need authentication mechanism. For the SQL server, it is username and password. For your local computer, it is again username and password. So similarly, for your cloud, GCP cloud also, there is a authentication mechanism that you need to follow. Okay, because your local system doesn't authorized to connect to your Google Cloud platform until unless you make it authorized. Correct. So to achieve this authorization functionality, we will create a credential file for your GCP project. Okay, we will create a credential file for your GCP project. That credential file we'll call it as a ADC file, application default credentials. Okay, ADC, application default credentials. So we create this file, and using this file, anybody can connect from any system to the GCP project that you have created. Okay, so this is the credentials mechanism that we will use in real time as well. Okay, so if you are connecting to your Google Cloud from your on-prem system, or if you're connecting to the Google Cloud from any kind of a third-party system, right? So you will use this ADC file. We call it as ADC file, application default credentials file. So it's a JSON file. So you need to generate that file in the Google Cloud platform. Then only that file you can provide in the authorization process. Okay, so let us understand how you can actually generate that ADC credentials. So it is pretty simple and straightforward, guys. So there is a command called gcloud authorization. So let us see here. So this is the command. Okay, so you just go to this Vertex AI notebook and then use this command gcloud auth application default login, and then once you use it, you just press Y. Okay, it will give a URL for you. Okay, and then it will ask for the verification code. Okay, so you just copy paste the URL in the next window and then sign in with the Google account that you have logged in. Okay, and then allow. See here, you will get a verification code. You just copy this verification code and paste this here, enter. Okay, so now your application default credentials has been stored in this location. Okay, you just cat this file. Okay, this is a JSON file, and you can actually use this JSON anywhere and write or authorize to GCP platform. So this is a process to create your ADC file. Guys, anybody have any questions?
So Venkat, I have one question.
Yes.
Yeah, so every project have this ADC file.
Yes, every project have this ADC file. Yes, if your project is being accessed from any kind of a third party on-prem system, or in your project, if they want to follow a strict authentication process from service to service, then yes, so every project will be having this ADC file. This ADC file is a project level and
Okay,
user
it is
level.
mandatory that every project would have, right?
It is not mandatory. The reason is, for example, you are using Google Cloud and then Google Cloud Storage and then Dataproc and then BigQuery, everything in the same project. You don't need any kind of a ADC authentication as such. You can directly communicate. Okay, but if you want to access that service from any kind of a third party system, for example, I want to access this Google storage from my local Windows machine, then I need this ADC file to authorize. Okay, from simply from Vertex AI notebook, you did not authorize anything. You were able to connect to JCS, correct?
Okay.
So like that, if your project involves any kind of third party system to Google Cloud authorization, then definitely you need this ADC file. There is one more case where actually you need this ADC file. Let us say you need impersonation. Okay, impersonation. So this is one more process. We call it as in. Uh, okay, what is this impersonation? Okay, let us say I'm calling from the data proc. Okay, I'm just calling big table or big query. Okay, so data proc in that project can easily communicate with big table or big query in the same project. Okay, we don't need to provide any kind of authorization for it, but few projects will follow a strict access related policies, or few projects will follow a strict access related standards. So where actually they will create credentials or ADC file for specific user. For example, I have created the data pipeline, and this data pipeline is reading the data from the storage, reading from the cloud storage. reading from the cloud storage, and then process in Dataproc, and then load to Bigtable or BigQuery. Okay, now if I want to create this kind of a data pipeline, what will happen? So I can seamlessly go ahead and create this data pipeline. I don't get any kind of access related issue. So let us assume this data pipeline should be created for a specific user access or for a specific generic account access. Then what we can do, we can always pass our ADC file between these services calling. So it is not needed, but there are few services which actually needed the impersonate credentials, right? So for example, the big table service. If you want to access big table, you need to pass this ADC file. Similarly, if you want to access some other services from other projects, or from your project to other project, you need to access a few of the services, then you need to parse this impersonation, right? For example, simply I will tell you one example. Okay, so you have the project, right? Yes, previously in our previous session we have seen dev, test, prod. Okay, now in prod data, I have the big table service. Okay, I'll just give you one example where we use these credentials inside the GCP. Okay, from the other systems to GCP, obviously we need the credentials, but inside the GCP where we will use this ADC file. Okay, so now let us take an example in the prod data or prod data analytics. I have a big table service. Okay, and here I have a big table service. Okay, now here I have a table name called EMP, and here I have a table name called EMP. Okay, now this EMP table is getting loaded from a data pipeline, and that data pipeline is also loading data to this prod data EMP table. Okay, now this prod data EMP table is accessible across all the projects. Correct, because it's a shared project. Now if you see, I have another project where actually I have Vijeta hyphen prod hyphen data analytics. Okay, and this project needs to access this shared bucket service called big table and this table EMP table. Okay, in that case, this project should create get should create the ADC file for it, for this project, and then go and access. Okay, so remember, I'm just telling it is in case of big table only. Okay, but you don't need it in Dataproc, or you don't need it in BigQuery or and all. But you need this kind of impersonation in big table. For example, if you want to access from solution project to shared project, big table tables, then we need to provide access or ADC file. Are we clear, guys?
Yeah, Venkat, thank you.
Okay, so this is the importance of this ADC file. Okay, okay, so we are already running out of time. That's okay, fine. So today I'm giving you one task, guys. So I want you to go and explore these Linux commands by tomorrow. So tomorrow I'll ask you people about few Linux commands. Okay, so that is the task for you. So go ahead and explore about the Linux commands and understand how Linux commands will work. What are all the different Linux commands that we have? So go ahead and learn about these Linux related things. Okay, so every time when you are logging out of your Google Cloud platform, make sure you're stopping your Vertex AI notebook. Otherwise, it will eat your entire cost. Okay, so you can still save that cost by stopping your Vertex AI notebook. So just select it and then stop it. Okay, so it will be stopped. So this is one thing that you need to remember. Otherwise, your free credits that you got will be lost. Okay, so that's one thing. And then today we have seen how to create storage buckets and how we can actually upload files from Vertex AI machine to Google Cloud Bucket. Okay, so along with the Linux commands exploration, there is one more task for you. Okay, so here if you see, I have a directory in my Vertex AI notebook. So the directory structure is /home /Jupyter slash data slash raw. Okay, and in this directory, okay, in this directory, I have 100 files. Okay, I have 100 files. Assume in this directory I have 100 files. Okay, how you will get 100 files? It's your call, guys. You can create random files with the Python script. Okay, and generate 100 different files, or else you can create you just write a simple Python script to create 100 files with the same content, right? So it's just a simple two-line Python code. You can do that. So at this moment, what is Python? No. Okay, so you should go back and recollect our Python sessions. Okay, so this is the time we already we will start from tomorrow. We will use Python like anything. Okay, so go and refresh your Python related stuff, guys. So we have spent good amount of time in Python. Okay, so here if you see, I have 100 files in this directory structure called raw, and I want to copy these 100 files at a time to my Google Cloud Storage bucket. Okay, this directory. Okay, so remember what is the task, guys? You have 100 files in this directory. You need to copy these 100 files at a time to this Google Cloud Storage using the Linux command. Okay, using the Linux gsutil Linux command. Okay, so this is your task, guys. So you explore about Linux commands and then try to complete this task. I'll ask in tomorrow's morning session. Okay, so that's all I have for today. We'll connect back tomorrow, and tomorrow we will be discussing on two things. One is Python based data loading and operations on Google Cloud Storage, and another one is NiFi based data loading. Right, so that is very important. You can use this NiFi tool in your project explanation also. It's a very powerful tool. Okay, so NiFi, I'll give some introduction to the NiFi in tomorrow's class, and then we'll proceed with that. You don't need very in-depth understanding on NiFi. You just see it as a data ingestion tool for now. Okay, so NiFi based Google Cloud Storage connection we'll see, and then Python based Google Cloud Storage connection we'll see. Today we have seen buckets creation, and then interaction between or communication between Vertex AI notebook and then Google Cloud Storage. And we also know how to generate the ADC file, right? So these are the things that we have seen today. In our tomorrow's session, we will definitely focus on the two real-time implementations of data loading in data loading to Google Cloud Storage. Okay. Any questions, guys? Any questions or queries? Come on, guys.
No.
No,
Yeah.
Venkat.
Okay. So Ranganath, Prakati, do you have any questions? Are you able to understand?
Yeah, yeah, Venki, no questions.
Okay. So please try to complete all the Python practices that you need to do, guys. So from today, it is people who did not practiced any Python till now. From tomorrow, you will see very hard times. Okay, you don't understand the sessions that we are discussing. Python variables, for loops on the fly. I'll be using a lot many Python related stuff. So you should go and recollect all those things from your Python sessions. Okay, people who did not started Python yet, please start practice. Okay, so this is for everybody, guys. People who practiced already, go and refresh your skills. Okay, so that's all I have for today, guys. Once again tomorrow. Thank you so much for joining.
Thank you, Venkat.
Yeah, thanks, Venkat.